Okay, this is problem 119. To draw it, first thing to do is draw yourself a good free body diagram. So come down here, draw just a rough sketch of the beam itself. Kind of like this. Go ahead and locate your forces. You have 12 kips here. Now break this part into one force. That's 3 times 12. That's 36 kips. Go ahead and show the reactions coming up here. Reaction coming up here. Get a little straighter. Maybe if I make it straighter. And the other one come up here. Okay, go ahead and label that as your FA. Or if you want to, let's call it AY. This would be my BY. This would be my CY. This would be 36. This would be 12. And then we know this distance here is going to be 6. This distance here would be 12. This distance here is going to be 18. And this distance here would be 24. Okay, again, take a moment at any point. I'll take a moment at A. If I sum my moments at A, I will get minus 12 times 6 plus BY times 18 minus 36. Oops, excuse me. Mistake. BY times 12. Be real careful here that you take your time and get this, right. You can't mess up in the distances like I'm continuously doing, but it's 5 a.m. in the morning, so 18 plus CY times 24. That'll give me minus 72 plus 12 BY and I don't know what 36 times 18 is, but let's see what that is. Minus 648. Again, these are all equal to 0. So just simplify that best you can. That's going to give you minus 576 plus 12 BY plus 24 CY is equal to 0. If it's me, I would simplify that. So I'll divide everything by 12. You don't have to, but it's just going to make it easier. If you think it's going to cause you an error, then a mistake or something, I wouldn't do it. Okay, there's your first equation there. Okay, second thing you want to do is sum your forces in the y direction, and actually we can do it right up here. I do it here, sum forces. Y equal to 0. I'll have AY minus 12 plus BY minus 36 plus CY is equal to 0. That gives me AY plus BY minus 48 plus CY is equal to 0. So the other equation I'm going to have would be minus 48 plus BY plus CY plus AY is equal to 0. So you have two equations. The problem is you have three unknowns here. One thing you could do at this point in time, if you wanted to, would be list these. Again, you don't have to do this, but okay, one thing you could do right here would be to multiply everything, and I'll do this in blue, multiply everything by -1 and then add these two together. And when you do that, you're going to lose your 48, you're going to lose your by. Here, you're going to get a new equation, minus cy plus ay is equal to 0. Alright, so you can kind of hang on that. That's a useful equation. Okay. Now what we want to do is we want to use the equations that we know in the back of the book, and we're going to find some deflections here. What we want to do is pick a point where we know deflection is going to be 0. We know the deflection here has got to be 0 here. So first thing to do is just make yourself a I'm going to grab a copy of the beam itself and talk about that real quick. Okay, come down here. Okay, at this point in time, what you want to do is you want to go back to your equation list. And on your equation list, we're going to look right here for this one. This looks like number 5 on your table list of graphs. Now, so go to the equation, and you don't want max deflection, you just want some deflection. And the equation that is given is going to be y is equal to p times b over 6 times E times I times L over x cubed minus L squared minus B squared times x. That's the equation given in the back of your book. Now, the only thing I'm going to recommend is, if you look at the picture in the back of the book, the force that's being applied is to the right side. So what I would do on this one would make this distance be the B value. Sorry, make this distance be the A value, and this distance would be the B value. So basically, I'm just flipping this beam around. Okay, and then your L is going to equal to 24. Your X distance here, since we're flipping this, X is going to be 12 here because we're trying to find the deflection there. Okay, now we'll put everything back in, and we're going to get Y is equal to P, which is B12, times my B value, which will be 6, and that's 6 EI, times my total length, which is 24, times my X distance, and we said X is going to be 12 because it's going to be basically the distance from here to here. And you do a few. I'd recommend you do a few of these before the test, and I think you'll be alright. That's going to give you 12 cubed minus in parentheses L squared, which is going to be 24 squared, minus B, and B value would be 6 squared, times X value, which will be 12. Okay, run that quickly in the calculator. We'll see what we get here. And I would do what's in parentheses first. Be probably easier. Okay, and that's going to give us a value of minus 2376 over EI. Okay, so that's going to be the deflection, we'll call it V, as a result of the 12. Okay, so hang on to that guy right there. Okay, now what you're going to do is you're going to work it regarding this. And the problem being, in your book, I'm trying to think. Let me look at your table. I'm not sure if you have that equation. You don't have one. I'm going to work it based upon another one, but it's going to help you as far as how to solve this problem. When you have a distributed load like that, there is going to be an equation for that, and let's see if I can grab that value real quick. It's going to be equal to, just based upon this one, would be the V, the deflection at B, is equal to, and the equation for this one is 5WL to the fourth over 768 EI. Okay, so we're going to put those numbers in with this distributed load here. That gives me 5. My W value here is going to be 3 times my value of L here is going to be 24 to the fourth power over 768. And that value gives me 6,480. Again, that would be minus over EI. I should make this minus 2 because we're doing minus deflections. Okay, now your last step, the only thing else is called as deflection is FBY, which we don't know. Again, you go to your tables, you look at a point load, and this time it's actually in the middle, so you can use the max equation if you want to. So you can do the VB, the deflection at B is going to equal to, let me change this color. Again, you're going for a point load in the middle, and you can either use the equation PL cubed over 48 EI, and that's going to be the simplest, or you can use the equation P over 48 EI. Again, this is just coming right out of the table. Make sure I get that one right because I don't want to mess this up on you. And that's going to be 4x cubed let me change that. Minus 3L squared times x. Okay, I would always use this approach because it's occurring right in the middle, and that means where the maximum deflection is going to be. You can use this, it's just going to increase your risk for making a mistake, but this is fine. Okay, so we're going to go back and do this one right here. So we do VB is equal to P, and that's going to be BY times L, which will give me my L value will be 24 cubed over 48 EI. Now that FBY is going to be pushing up, so that's going to give me a positive deflection. We run that value, and that's going to give me 288 BY over EI. And again, that's plus, these two are negative. So there's your three values here. Now all you really have to do is set those up as equal to 0. You do 288 BY over EI minus 6480 over EI minus 2376. EI, set that equal to 0 and solve for BY. Now notice here you can cancel your EIs. You multiply everything by EI, these are gone. These are meaningless. And when you do that, you'll find out from just this that BY is equal to 30.75 kips. Here, at that point, go back to your original equations, and here it doesn't really help you, but you can put it back into, let's see what we could do here. We could actually put it back into one of these, this equation and this equation here, and what you'll end up getting is you'll be able to, you put it in here, you'll be able to find CY. Put CY back here, you get AY, and then your values here would be AY is equal to 2.625 kips, and then your CY will equal to 14.6 kips. Okay, and that's how you do the problem. I know it seems complex. You just need to work a few of these problems. They're not too bad. It's just you got to be careful about laying out your equations or your pictures to match what your formula sheets are going to look like. If you're careful about it, you can nail these problems without any trouble.